In this lecture, we are going to discuss about zeros of analytic function. First is the definition of the zero of analytic function. The value of z for which the analytic function, the value of z for which the analytic function fz becomes zero is called zero of fz. That is, if for z equal to z1, my f of z1 is 0. If I replace z by z1, above z1 is 0, then z1 is called 0 of analytic function. If fz is analytic, in a domain, D, and z node is any point, in D, then fz can be expanded in the Taylor series about the point z equal to z naught given by fz equal to sum over n ranges from 0 to infinity a n z minus z naught to the power n. If a naught a1 up to a m minus 1 is 0, but am is not 0, then fz is said to have 0 of order m, 0 of order m at z equal to z naught. In this case, Taylor series expansion of fz about z naught is given by about the point z naught is given by fz equal to sum over n equal to here started from m, as all the previous coefficient become 0, infinity a n z minus z naught to the power n, which can also be written as n equal to 0 to infinity a to the power n plus m z minus z naught to the power n plus m. So that if we put n equal to 0, this will be am z minus z naught m. If I put n equal to 1, it will be am plus 1 z minus z naught m plus 1 goes on up to infinity. So this is the required infinite series Taylor series expansion of fz about the point z naught. Okay, a zero of order 1 is called simple zero. Okay, simple zero. Next is example of zero of analytic function. Consider a function fz equal to z square minus 1 by z square plus I plus 1. Okay, not I, plus 1. Then zeros of fz are obtained by equating numerator to 0. Zeros of fz are equating obtained by equating numerator to 0. This implies z minus 1 by using the formula a square minus b square, that is a minus b, a plus b, that is z plus 1. Okay, z plus 1, z plus 1 equal to 0. This is equal to z equal to 1 and minus 1, which are simple zero of fz, simple zeros of fz, zeros of fz. This is like this. These are simple zeros. Okay. Next, again consider this is number one. Number one. Next, number two. Fz z minus 1 whole square z square by divided by z square plus 9. Again, zeros of fz are obtained by zeros of fz are obtained by equating numerator to 0. This implies z equal to 1 is 0 of fz of order of order 2. Okay, as here power is 2, so z equal to 1 is a 0, is a 0 of fz of order 2. With that, I would like to conclude. Remaining will be in the next lecture. Thank you.